times. And it was just the best part of the conference room. That's okay. This is by Basil Tree, by the way. So if you're catering locally, I highly recommend them. And if you go to Game Loop, then that should be very familiar sandwiches to you. So, up next, we actually have 2 speakers for this one, if your tiny minds can even keep track. One of the people up here is Heather Decker-Davis. Behind me. Heather's a designer and artist at Overlord Games. She also works as a lecturer in game development, most recently at Clinton Community College in Iowa. After discovering the Commodore 64 and crayons early on in life, Heather's been incessantly making expressive things, often with groups of wonderful people. She proudly serves her local game development community as secretary of the IGDA Chicago Board of Directors and is an alumni of the IGDA Scholarship Program. Heather writes for AltDev Blog a Day, with articles featured on Sutra and Game Career Guide, and chaired the recent AltDev Conf, a community-centered virtual conference. And then this gentleman behind me is Mr. Luke Dicken, whose bio is taking its sweet time to load. So.
It's pretty dull anyway.
He's just some guy, you know. There we go. Luke Dicken is the founder of Overlord Games and a researcher with this, all right, you're going to tell me about Strathclyde?
Yep.
Hey, Strathclyde Artificial Intelligence and Games Group at the University of Strathclyde in the UK. He's a 2-time IGDA scholar, contributes to AltDev Blog a Day, and was one of the organizers for the recent web-based AltDev Conf. Luke has been passionate about artificial intelligence since playing creatures as a teenager and pursued it at university, first through several degrees in traditional AI, before specializing in AI for games as part of a PhD he is still occasionally pursuing. Luke is a member of the AI Game Programmers Guild and recently took over as chair of the IGDA Special Interest Group on AI. Please welcome them to Neutral Conference.
Hi folks. You have all made a very wise edutainment choice after lunch. Thank you for being here. We're going to talk today about some work that we've been doing on a game called Easy Money, and the way that automated content generation has shaped our thinking and our working. So apparently, this is something new that's new to me, but if you put your Twitter at the front of the presentation, people will include you when they're bitching about you and heckling, so feel free to do that. So, a little bit about Robot Overlord Games and what we're doing. So this started as me, and it's still mostly me. So I was sort of doing some AI things, and I wanted a name to do it under, and that's where it came from, and I started making some prototypes, and then I started taking on some AI work for hire kind of gigs, and then I thought, well, this is all well and good, but nobody really cares about AI if it doesn't look nice. Fortunately, Heather was kind enough to come on board, so we now have a resident designer and artist with us. There we go. And Heather had a project that she was working on for her Master of Fine Arts thesis. We took that and we're now running with it, and we are now Robot Overlord Games as a pair. So it's like a Wonder Twins Unite kind of thing. So the game that we're working on, like I say, it's spun out of Heather's thesis, and it's called Easy Money. It has a logo as of yesterday. It's a casual title. It's based around management of risk and reward, and the hook with it is that it has like a Who Wants to Be a Millionaire death penalty, where you go home with nothing if you die. And then we threw a leaderboard on it just to make it interesting. So you try and sort of collect all the cash, and really rise up through the leaderboard, and if you want to get more, then you risk dying and losing everything and wasting a good sort of 10 or 15 minutes of your life, but hey, it's a Facebook game, that's how they go. So I'm going to hand over to Heather now to give you a demo and to talk a little bit about what's going on with this game.
Yes, indeed. Alright, so here's a screenshot real quick. Alright. So, just a quick demo here, showing you how the game goes. You roll around as a professor level, and if you want to collect all the funds you can, or as much as you can. But unfortunately, sometimes it's a little difficult. And if you fail, you come away with nothing. So, tough luck. Now, at times you grow so much that you have to actually downsize to shrink your spaces. It's an important part too. You get a goal. then lastly, there's times when you might just decide, hey, that looks bad. I think I'd rather keep what I have. And then you can log your high score. So that's basically how it works. So the first question you might ask is, why would I want to generate things procedurally? Well, lots of reasons. First off, players have come to expect a lot of content in games. So that's one important reason. And traditionally, we've been building this content by hand. That's all great and fine, but there are also some inherent problems with static content, as I call it. First off, basically, players can end up memorizing their levels. At that rate, it's not as much about their particular skill as much as how good they are at actually memorizing their levels. Not maybe what you're shooting for. Secondly, if they've memorized your levels, they've played through them, they know what they are, they tend to get disinterested with replaying the same content. That's when you end up with people taking your name back to GameStop and trading it in and all that sort of thing. So, and then, procedural content generation can help you keep your game fresh. An example here would be Temple Run. If this game were actually framed as a game with static content, it would get pretty old pretty fast. Oh, here's where I jump. Here's where I turn right. Here's where I turn right again. And it's just not as fun as when it's procedurally generated. It's constantly keeping you on your toes, and you don't know what to expect. You have to react to it. So that's an important component of a lot of games. And lastly, you might be interested in procedural content generation because it can help you with storage issues. For instance, it's a lot easier to store a little algorithm than it is to store large sets of assets, like levels and maps and all of that sort of thing. So, procedural content generation in this game makes money. Basically, one of my design goals here was to facilitate the constant race to the top that Luke was talking about. And static content was kind of at odds against this. Basically, we would have people memorizing levels. It wouldn't be about their skill or whether they could judge whether it was a good idea to move on or not. So basically, we needed an ample set of levels to achieve my goals here, and procedural content generation could help us with this. It'd be more about skill than people memorizing things, as previously mentioned. The mazes are generated semi-randomly, and then we have items that are deployed semi-randomly. And today we're just going to talk a little bit about how everything comes together and how procedural content generation impacted our workflow and overall results. So when you're developing procedurally, it's more about setting up conditions for an envisioned range of possible player experiences than it is about crafting specific content, specific levels, specific linear experiences. The terminology I like to use for this is static levels, the term for crafted levels. Say something like Peggle, where a level designer has clearly laid out all of these pegs in a specific order. That's static content as compared to something like Bejeweled, which is procedurally laid out. They're just randomly laying out all the chunks for you. It's not as deliberative. So since many games actually follow the whole static content model thing, you might actually be used to developing this way, and you might need to break some of your previous habits to actually keep yourself in the right mindset for developing procedurally. And on that same note, designing procedurally can be a little different. You're designing interactions for a space that doesn't exist yet. So you might be able to put yourself in a different design mindset at that rate. You're thinking about spatial challenges, and at that rate, you need to think about the realm of possible results you could get. And at that same note, you want to be aware of any potential unplayable situations that could result. You don't want to immediately trap your player or immediately give them a situation they could never overcome. So at that rate, you need to actually build in constraints to prepare for that. And it's also a good idea when you're looking at procedural content generation systems to work on prototyping your mechanics first. Like I did a basic little game mechanics prototype to make sure it's actually fun to roll around and pick stuff up and worry about shrinking down. You don't want to end up building a procedural content generation system for a game mechanic that isn't even fun. You don't want to put all that effort forth. And we're going to talk more about that, of course, too. And with the procedural content generation, you want to take a more system-oriented or formulaic approach to your progression. You aren't going to hand plot out these things. You need formulas and so forth to do this for you. So you need to identify some variables that are going to help you with this. take some testing, as always, just a little different on this grade. As far as choosing your variables, you want to make sure you're selecting variables that seem fair to your player. See, in easy money, it's like, okay, yeah, the mines there's going to be more mines. That's fine, and you have to react a little more. If I were to say, oh, I'm just going to make it harder for them to control the bubble, and no one likes that. It breaks their sense of fairness. You have to pick the appropriate things to follow your goals, basically. And at that rate, you also want to test the extremes of the variables you've selected. If you find a good start point and a good end point, then you can build a formula that'll fill in all the areas between those points. Nice little difficulty curve there. Basically, linear equations are always a good starting point for this. Nice, straightforward, gradual progression, easy to control. You can take it a step further from there if you want to. Tweak it. Maybe you want the end of the game to feel all that much harder. So all of a sudden it just goes a little farther with that. Onward to asset creation. Generally speaking, you want to involve your artists early on. Get them involved while you're actually building the procedural content generation system, because it's going to be a little more challenging. They might not be used to thinking of it that way. It's not as simple as this looks nice and this looks nice together. We have no guarantee those two things are ever going to be together in a game, or at least maybe not as you thought they would. So artists actually have to start thinking modularly and consider all the possible ways that these assets could come together as a musician. We've of course encountered this before in like level editors and so forth. I know you think modularly about assets in those. There's some similarities, but some subtle differences. Like maybe in the level editor, I can decide that, hey, this mesh is always going to be against a wall, so the backside doesn't matter. Well, the artists have to actually consider more about the different possibilities. If it's not programmed into the system, then you have to be designing all the assets to actually accommodate for any possible positions they could be in. So, of course, there are several different approaches to actually developing the art here. You could look at developing one solution and then spinning off several theme packages, add some variety of things. You could do some color shifting after you've developed the one kind of solution to your art answers here. You could also look at procedural texture. That's another option, but be aware that if you're dealing with procedural texture, it tends to form visual patterns, and those might not line up as you had intended. Always good things to think about. Specific to this game, Easy Money, for the art style, I went ahead and embraced the level structure when I was tackling the art. I wanted this old-timey steampunk carnival kind of sideshow thing, and as a result, these riveted cuffs were a good tool I could employ to kind of make everything mesh together well. I mentioned that you want to bring the artist in early because it might take a little trial and error. It definitely did in this case. Had to play around with it a little bit. We're going to need to figure out the best approach, so testing and prototyping is going to be necessary. Basically, speaking of prototyping, once I've figured out what my general characteristics are at the level, created some 2D tiles that help us with prototyping the level generation system. This allowed us to actually refine the level generation system as well as the actual piece sets. So we weren't really sure what was going to make the kind of levels that I had envisioned, basically. So we played around with it, prototyped it a bit. Once we'd actually, doing this in the 2D prototype format made it easy for me to swap things out. And Luke had formed this great system where I could easily put pieces in and take them out depending on whatever I wanted to do, change the setup at any given time on the fly. Made it a lot easier to actually refine this whole system and the set of tiles that we were using. And the prototyping actually took off in a few different stages. First we started with this 2D representation I talked about. Then we went ahead into actual 3D explorable levels that people could roll around, check it out. Then we moved on to actually adding the funds, the pickups that people would get. And then we finally incorporated the hazards as well. And tackling art, as mentioned, I started with 2D tiles, and they were good blueprints or templates for actually building 3D forms. I didn't have to worry about wasting art assets. Oh, I'm going to build this model, and then I'm not going to use it. No. The 2D prototyping made it to where I wasn't being wasteful about my time. I paid careful attention to the scale and the structure to make sure that everything was snapped together well. It was important to be very, very neat in this case. You can kind of move things around by hand when you're dealing with static content, but everything was snapped together well when it's placed on a grid. Once all the models were actually passed, I tested them all, they passed in my mind, looked good, then I could actually go in and texture them. I just unwrapped them and textured them each individually. And with this particular engine, it was important that I make sure to pack as much into one texture sheet as possible to minimize the drop calls. So, as you can see, lots of stuff crammed in there, fonts and level alike. And each of these things, they have individual UVs, but single limit for all the textures. And packing them up aside, maximizing the reusability here, as mentioned, all the walls for the server is the same, the little halls that come off, they all use the same pixel space. So anything I could reuse, just up my efficiency basically. So now I'm going to hand it back over to Luke. We're going to talk about actually putting it all together.
Okay, so we've got nice pretty bits of art now, which is nothing to do with me, I just do the algorithms and stuff. So I'm going to talk now about how we make mazes. So first off, making mazes isn't particularly hard from a computer science point of view. I mean, writing an algorithm that can sort of drop some stuff into an array and build up a maze, it's not rocket science. So the biggest challenge really is how you're going to represent that in your engine. And I don't really want to get into that, it's not a code tutorial, I want to talk about concepts. So I'm going to skip over all that and assume that you can make a maze generating system yourself. But just as a broad sort of concept, what we're going to do is we're going to place the appropriate piece for the maze anywhere that's got a road to nowhere. So anywhere that there's just a sort of bit of maze that doesn't go anywhere, we can come along, slap something down, and then move on. This is a really efficient way of doing it. It's incredibly efficient. So we started out when we were thinking we'd want mazes maybe 20, 30 kind of tiles big. So using the 2D prototyping stuff, we could generate that and dead easy. We were kicking those out really quite fast. So I thought, okay, well, I had a couple of drinks one night and thought, let's see what this can do. So for fun, I started cranking it and cranking it and cranking it, and it turns out that it'll start to chug when it gets to about 30,000 pieces. So we were quite happy with that. And even then it's only taking a few seconds to kick something out like that. So, very efficient approach, quite happy. We've got this algorithm that does this. You can actually read it on the screen, excellent. We weren't sure that you'd be able to see this, but you have, basically this is a flowchart representation of the algorithm, so from this, you can pick it up off the slides and encode it up yourself. But you place the start room, and you say, okay, well, the start room has a piece coming down to the south, and then we do the road to nowhere maze placement from there. We have a worked example, so I'll show you here. So this is the start room going up, and that is the south connector. So from this point, we need something that has a north connector. So there we go. And then we want something to join up to that, so we need another north connection on that. There we go. This time we've picked something to go to the west, so it needs an east. And again, we're picking these at random once we know what's appropriate. So from the appropriate pieces, we pick something at random. So this one was a dead end, but it doesn't have to be. This one here, though, is a little bit different because we know that we can't go north with this one because there's something in the way that doesn't have a corresponding south. So we're changing what's appropriate, which we're sort of aware of that and making sure that nothing bad is going on. And again there, so we just grow the maze just like you would, almost like a tree. It's just a case of straightforward stuff, and we're using the assets that have come from Heather to, so we're working in like an array, dropping the piece in and finding the corresponding art asset and putting that into the world. So here, that one is a little bit more interesting because that one has forced a north as well as the thing to join it up because there was a corresponding south. And we just keep going, building things up, and it's, like I said, a very efficient process. Not when you do it on slides step by step like this, but you know, when it's running, it does run quite quickly. And once we get to a point where we've got enough pieces, so we reach a maximum size, then what we do is we terminate every road to nowhere. So we just come through and slap these dead end runes on every unterminated ending. And that should be all of them. Right, so that's fine. We've now got a maze. We've got a maze that we know is complete, it's fully connected. There is no way for the player to escape from the maze. There's nothing for the player to do in the maze though. So then we go through and we pick one of these dead end runes and we replace it with a goal rune. So the star represents the goal, the circle in the top middle there is the starting point. So we've generated the maze, we know where we're going, we know where we're starting from. But we still have to pass through verification because although we know that we're going to, just by the nature of the algorithm that we're using, we're going to get a fully connected maze, we don't have to worry about that. We actually need to verify that it's going to be interesting for the player, because we could just generate some random stuff and go, okay, we'll go play with that, and if it's not fun, they're not going to enjoy playing it. So we use a few simple tricks to verify the maze. The number of dead ends that we have in the maze is important, so we use that as an estimator of how many times the maze branches. It's not quite as efficient as counting the number of branch points, but it is also very quick. We can get that information very efficiently. We take the straight line distance from the start to the end. So again, these are all sort of heuristic estimates. It would be a more complex computational problem to calculate the path through the maze from the start to the end. But the straight line distance gives us a rough guide to how far away the two are. And finally, the number of pieces that are in place. So we talked about how it was going to create a fully connected maze. Well, what could happen is that first southerly connector could join up to something that's like this. And then it just forms one loop with 4 pieces, and job's done. So that's not interesting. One loop isn't interesting. So we want to make sure that we actually have some minimum threshold pieces to actually make a complex space, or a complex-ish space. And if any of these checks fail, if we don't like anything that's happened, we throw away the maze and we generate a new one. And that often raises eyebrows when we tell people about that. So this is a slide where you can tell I'm an academic heart, because we have Latin in the title and we're about to talk about some computational complexity. This comes up every time we sort of talk about this stuff. Why are you throwing this away rather than actually shaping the generation of the maze? And the answer is that it boils down to the P versus MP problem, essentially. Because verification is a very simple process. And guiding the generation is way more complex. So do we want to solve a very simple thing multiple times, or do we want to solve a complex thing once? And it turns out that for us, we're okay solving the same thing a few times and having it be very simple. Your mileage will vary if you choose to implement this. For us, we found that about 1 in 50 mazes we rejected, and a maze was being generated in something like 2 milliseconds. So a quick bit of maths that I've actually got in front of me on the screen, I'm not doing this in my head. So that's, the probability is 2.56 times 10 to the minus 14 that we're even going to delay over a single frame in the number of times that we reject. So rather than wasting the time every time trying to shape the generation, we can just rely on the fact that we reject with a low probability and just whip through it. So that's that one justified, and I think finally we'll put the detractors to rest, I hope, because it keeps coming up and we've never had a good answer, so we sat down and wrote a good answer for this, this presentation. So okay, changing tack a little bit, analytics. So analytics are important, and I hope that everybody would agree with that. This guy certainly would. So working out what you're doing, what the player is doing in the game is so important, because that's going to shape what you want to do next with the game. And having gathered all the stats, having done your analytics, you actually need to look at them, which is something that oftentimes is problematic. So people gather these big data sets and then sit with them on the desks or in the machines, and they never actually start trying to dig into what's going on in there. So, analyze all the data. So in Easy Money, what we do is we use a web service system built on PHP and MySQL, and we ping out from the game engine whenever things that are interesting happen in game. We ping out to the web service and store it in a database. And that means that when we get to the end of some milestone, we want to see what's going on, then we've actually got a summary of every game that's been played with it. And we can see, this is the game ID, this is the player ID, and this is a summary of what happened in that game. So sometimes the player will have died, sometimes they will have cashed out with a score, and sometimes they just closed the browser because I guess they didn't like it or something. It hurts our feelings a bit, but we try and deal with it. And more than that, we can also drill right down and get almost like a narrative of exactly what happened in each game, just by logging the events. So we log the events and we've got that information in front of us. That's powerful for a number of reasons. We're going to talk a little bit in a second why, but it's also powerful from just from having it from a debugging point of view. Because when somebody on your team comes along and breaks the scoring system, so that everybody is scoring like 10 or 100 times more than they were the day before, you can actually trace back when you notice it a week later and work out what time that started happening, trace it back to the source control and find out who missed out resetting a variable. It's all good, but having those tools available just from a development point of view is amazing, because you can actually go back and find it, and once we knew what was going on, we could trace it back, diff everything, find what was happening, problem solved. Well, actually, we decided it was a feature, not a bug, but you know, oh well. Okay, but analytics in the context of procedural content generation, well, that's really kind of tricky, because we need to have context. We need to know what was happening when whatever happened in the game happened. So, for tracking sort of edge cases, where something weird has happened, we need to be able to replicate what the content in there was. So, we need to have the ability to export our levels. So when we've generated this content, we need to be able to actually store it somewhere. So we need to be able to serialize it. And we need to be able then to drag it back in. So we need to be able to bypass the procedural content generation system, at least for development builds, and say, okay, instead of doing this, let's actually put in this. And we can see what that player was doing that led to whatever crazy thing that happened that got a bug report. We can always track back by being able to export and replay. So we know this, we've seen it before with random number generators. When we seed it, when we store the seeds, and then we can replicate that random number generation. So, okay, so I'm talking about analytics. Why am I talking about analytics? Well, because procedural difficulty, because we can not only just generate content, but then we can start generating content based on who the player is and how they're playing the game. So we've got a parameterized approach already. We've got an approach that's already got stuff like how many pieces that we want to put in the maze and all the other things that I've told you about that I've forgotten. So, okay, there's a bullet point. For generation and verification for in-game properties. So it's not hard to see how we can start changing the values that these parameters are going to take as we go. So it's not a case of just sort of having them be set up and then generating things randomly. As we go, we can tweak the parameters and we can change the feel of the game over time. So we can create larger mazes, we can drop more lines in, we can make the lines move faster, we can increase the number of branches we have in the maze. We can do all of these things, but we can also do it in a way that manages the tone of the space. So this is an important key sort of thing that you might know from the game Tiny Wings. So Tiny Wings does this amazingly well. So every day there's new content in Tiny Wings, and that's all procedurally generated. So for those of you who don't know, Tiny Wings is a game where you play the little bird and he's trying to fly and he can't, so he falls out of the sky. But you can touch and make him fall faster, skate down the back of the valley, and then you flip up the hill and fly away for a little bit. The hills are all procedurally generated, but the first one will always be a nice, gentle, rolling kind of thing. So that's the tone of that. The actual specifics are going to change, but within certain parameter bounds, this is what it's going to look like. Then we have something that's a little bit later on, maybe 4 or 5, I've skipped over it. I don't know, these computer scientists say they can't do anything. There we go. Right, so this one's got really steeper valleys and hills, and it's really a lot more aggressive. It's a completely different tone. This is later on in the level. It's going to change as well, but it will always be the same sort of very steep, very aggressive kind of approach. So we're controlling them, and we're controlling parameters, but we're within bounds so that we can control the tone of the thing. So that means that we can change the difficulty, but not change how it feels. But we can then go further and we can say, okay, well, we've got all this data about the players. We know what that player is doing. So rather than adapting the game, we can look at how the player is actually playing the game and what they're choosing to spend their time on. And then what we can do is we can go into the procedural content system and we can say, okay, this is a player that likes this, or they like that. And we can change the game to suit them. So if we have a player who's preferring the exploration part of the easy money game, who's wandering about the level, making sure that they've got all the pickups, we can give them larger spaces. We can give them an area that they can actually go out and explore and more stuff to find. If we've got a guy who just wants to dash to the goal and not really bothered about picking up anything, he just wants to get there and dodge around the mines, then we can either give him that, we can just put the goal somewhere convenient, or we can try and screw him over and throw loads more mines in there, depending on how we feel about it. But the point is that we can react to what the player is doing in advance by developing a procedural content system that's aware of the player behaviors. And all this is a little bit pie in the sky. We've got it in development, it's not in the build that's available just now. But this is procedural signposting. So how can we guide the player around a space that we haven't actually created? So we've talked about sort of developing levels for the player, but actually guiding the player around and signposting. So signposting is so important in games that are being designed by designers rather than by bits of hacky algorithms. So in a first-person shooter, you might find that there's a light under it. There's 2 doors in a room and there's a light under one of them. And it's a subtle cue that that's the one that's important to go through. Another good example might be cover positions. So cover positions in a level are going to suggest where the enemies are going to come from, because if there's some overturned bench in your room, there's a good chance that it's been put there specifically to provide cover. So this is stolen blatantly from Insomniac Games. They have a really good presentation on this from GDC last year. But you can see that where that cover is on the bottom there for the player is sort of setting you up and building the confrontation such that you can see that it's created. So if we go for a procedural content system where we don't know in advance all this stuff, we have to provide these kinds of cues. So this is the kind of thing that we're playing about right now with Easy Money. And we're looking at how we can generate this kind of stuff on the fly. And really, what we're trying to do is use the collectibles and the hazards, because that's what sort of the game is about. So we can sort of focus on the critical path through the maze, the shortest path from A to B. I said that we didn't want to calculate it, but we can calculate that. And then we can choose to lay stuff along that path to guide the player. Or we could put more mines along that path to dissuade them. We could make sure that there are shortcuts about. So this is all stuff that we can use to actually shape the experience as well, procedurally, without actually having to monkey about and design things in advance. So that's everything from me. So I'm just going to turn over to Heather for the last few slides talking about the challenges that we faced.
Alright, so basically we started off talking about why you might want to employ procedural content generation, why it's great. There's also some things I could talk about on the flip side of that. First and foremost, it's not a silver bullet, it's not an end-all, a magical thing. It's good to have in the tool set, but that's about it. Basically, one of the things you can run into is that tools development and actually creating a content generation system can end up being some kind of quagmire for both time and cost. The most infamous example of this would be Spore. It was a very ambitious game, lots and lots of procedural content generation in it, but it went like infamously over budget and fell way behind schedule. So be aware that that can happen to your project. You also really need some strong programming muscle on your team. You're going to be doing a lot of debugging and a lot of refining of your systems. There's going to be some weird French cases that crop up. You're going to need to address this, build new rules. There's also a potential pitfall would be the sameness of the space. Sometimes these spaces that are generated procedurally end up feeling kind of cold and just predictable, autonomous at times. You can combat this. You can actually pepper in some unique content later on. Keep in mind that this is yet another feature in your content generation system that you need to plan the ample time to test and refine. Adding more features, more time, more problems. But it can be done to help, make your space more interesting. People who like to explore, in particular, are looking for new stuff eventually. They're expecting to walk to a new area or roll to a new area in this case, and see something different eventually. Another approach you could take would be to use a combination of procedural and static content. This is more commonly seen in like Diablo, you may be familiar with. Uses some crafted things, some levels that are already laid out, for quests and stuff, as well as some procedurally generated dungeons and whatnot. Now, other challenges include actually balancing the power of your tools. Just because you can generate nearly limitless content doesn't necessarily mean that throwing this all at your player is the right thing to do. Endless levels tend to conflict with the player's expectation that they have this goal and they're going to reach it. They like finite goals. They like to be able to do something, and especially in a casual game like Easy Money, it was important that it not take forever and a day to actually complete the game. So use your newfound procedural content generation powers wisely. Easy Money actually started out with 100 levels. As it turned out, nobody was very psyched to actually complete all 100 levels. We scaled it back to 25, and suddenly people were getting through the game. People were actually excited to get through the game. Whereas people were dropping off at about level 10 to begin with 25 levels, people were just clearing it like mad. It worked well. So again, be aware that just because you can generate tens of thousands, hundreds of thousands of different level options doesn't mean that that's necessarily right for players. It works for survival style games and that sort of thing, but again, case-by-case analysis of your game and your goals. And it also is worth noting that procedural content generation is not right for all types of games. This is especially true if you're talking about narrative-heavy games at times, especially environmental storytelling techniques. If you're trying to tell a story with your setting, not knowing what your setting is going to look like is a huge wrench in the entire deal. So be aware of that as well. In short, all developers should actually evaluate the pros and cons of procedural generation relative to their particular project before undergoing all the process of actually making all these tools and sinking all this time in. Be aware of the key question of, does this content generation system really benefit your game? Does it follow suit with your goals? Does it warrant all this testing, all this time? The methods I've discussed here, or we've discussed here rather, can be leveraged for all kinds of different games. You can use it for RPGs, action games, racing games. You can tailor it to all kinds of different level styles. This Easy Money example is just how we took it. This is our approach and what happened with it, essentially. You could also look at other well-known examples in the wild. Diablo 3 just so happens to have a similar sort of structure to it. It's essentially the same thing we've been discussing here, except obviously their levels look quite a bit different. And key things here, basically break your levels down into modular pieces. You want to establish the procedural content generation system early on. It's kind of critical to have the place where the game happens, when you're developing the game. Kind of a little important. And of course, the tight integration between your artists, your designers, your programmers. Your team needs to be working all collectively together. In this case, we had only 2 people, and we were able to communicate very well and work out all the problems, but be aware that there's going to be extra issues. It's going to affect all your decisions, but if you're aware of all of these things, you can actually leverage the procedural content generation system and crank the game up to 11, essentially. Alright, so there's actually an alpha online of the game right now. There's the URL, you can follow that, from Overlord Games. Currently working on more versions of that. And again, I'm Heather Decker-Davis, and this is Luke Dicken. And you can go ahead and email us if you like. Again, there's our Twitter handles there. And thank you so much for being here, watching this on the internet.
Yay, tech talks that I can't follow along with. But I'm not a technical person. That's fantastic. Thank you guys. We're going to take a 15-minute break, so we'll be back here at 3 o'clock for our last talkie, or no, not our last one of the day, for Andrea Schubert. Have a good market. So we'll see you guys next time.